ऑल राइट एवरीबडी, सबका स्वागत है लाइव स्ट्रीम में। तो कोरोना में कैसी कट रही है भाई? हैं? करंट व्यूवर्स भी कम है। चलो यार ज्वाइन करो तुम लोग। मधुसूदन शर्मा, हाय, हाउ आर यू? इतने कम लोग क्यों हैं यार? हैं? ऐसा ना करो। हैं? यो तांडव, व्हाट्सअप? समर्थ अग्रवाल, हेलो ब्रो। यार थोड़े लोग और आ जाते यार। हैं? हेलो दिया अग्रवाल, हाउ आर यू? जब तक यार आ रहे हैं सब लोग। गुड आफ्टरनून मैम। ऑल द बेस्ट, थैंक यू। ऋषिकेश, हेलो ऋषिकेश। स्वैगर, यो, थैंक यू थैंक यू। अरे यार एटलीस्ट 50 तो हो जाओ। अरे भाई स्वैगर स्वैगर ब्रो, थैंक यू थैंक यू। वेट कर ही रहे हैं, वेट ही कर रहे हैं। आप लोगों को आने में इतना टाइम लग गया। थैंक यू स्वैगर भाई, थैंक यू। यहाँ थोड़े से और लोग आ जाओ प्लीज़। हाँ, मैं थोड़ा सा खुश हो जाऊँगा। रिजवान ब्रो हाय। यो मयंक व्हाट्सअप। अरे मानिक सर आ रहे हैं, रुक जाइए। मानिक यार, पंगे क्यों ले रहे हो? Hello everyone, welcome to the live stream. So today we'll be discussing about cloud computing. All right. और अगर मैं बोलूँ क्लाउड कंप्यूटिंग तो इसका मतलब ये नहीं है यार कि आसमान में या बादलों में क्लाउड रखे, कंप्यूटर रखे हुए हैं, ठीक है ना। क्लाउड जो है उसका स्ट्रक्चर समझो। द क्लाउड इज मेड आउट ऑफ tiny particles, maybe it's mist, dust, and lots of steam, right? The same way, these computers or this system computers can also be understood. यार क्लाउड कंप्यूटिंग सिस्टम एक कंप्यूटर्स का ऐसा सिस्टम होता है जिसको ज़रूरत के हिसाब से मॉडिफाई कर सकते हैं, कहीं भी तैयार हो जाता है, ठीक है, कहीं से भी चला जाता है ना। तो कमेंट करके बताओ यार, स्क्रीन दिख रही है? Guys, if you can see the screen, do let me know. All right. So basically, wait a minute. Alright, let's begin. So this is webinar on cloud computing brought to you by Nabhay Sharma from BTech first year and Tron PC, right? So let us discuss today in today's agenda first. So we'll be discussing the first and foremost question, what is cloud computing? Next, why do we need it? Then the classification based on deployment and services that cloud computing brings. Then we'll be talking about AWS, the Amazon Web Services, what are its advantages, basic features that AWS brings. Then we'll have a doubt session, and then before ending this, I'll give you a live demonstration how you can set up parse backend for your Android applications, right? All right, let us begin then. So imagine that there are two phones, maybe one belongs to you and the other belongs to your colleague. You are working on a file known as code.c, right? This is a huge file, like around 5 gigabytes. All right, so how are you planning to share this? Well, you have got so many services around, but wait, you can't use WhatsApp here because it has a limitation of 100 megabytes, right? You can't use Telegram because it is limited to 1.5 gigabytes, and there's no other such service you can use practically, right? So what else are you supposed to do? You'll ask him to turn it on, you'll use Wi-Fi, you'll use share it to simply share the file. All right, and if you tweak your phone, you can share this at the same time with 1, 2, 10, what about 1,000 devices, and your phone will crash, right? So what is the workaround if you want to share this file with multiple people? Here comes Google Drive into the picture. What you can do is you can upload this file to the Google Drive. You will receive a link. You can share this link to the person whom you want to share the file with, and the guy can use this link to download the file from Google Drive, and that is very easy. You can repeat this process once, twice, tens, even 1,000 times, but keep in mind Google Drive has a limit of 100 shares once the file has been uploaded. All right, so keep that in mind. Well, why doesn't this Google Drive crash? Look, your phone is not designed to respond to requests, though it can, but it's not designed to do so. It can respond to maybe one request, two requests, but not thousands of requests at the same time. The computers that are dealing with cloud storage are not the regular ones, not the i5 or the i7 computers that you have in the consumer base. They use computers such something like an Intel Xeon or like something Epic, AMD Epic, or something like a AMD Threadripper, right? So these are very powerful computers. They can handle the storage very well. They can handle requests, and it works buttery smooth, right? All right. So the next thing over here is what I wanted to tell you. WhatsApp uses the same way to share files which are under 100 megabytes. Telegram also does the same thing. When you have to share a file to someone, it first gets converted into some lower quality, then gets uploaded to the server of Telegram or to WhatsApp, and then a link to the file is shared or forwarded to the person whom you want to share the file with. Alright, what basically I meant to say is, if you want to share a file with multiple people at the same time, you can upload this file to the cloud, and since cloud is spread all across the world, users around the world can download this file from the cloud itself, right? So let us form a general definition out of it. Cloud computing is the on-demand availability of computer data storage resources. Look, if there's anything you find it difficult to understand till now, tell me in the comments. I will repeat it once again in Hindi. Alright? Because today's motive is not me coming and speaking over here. Just a minute. So I think there are no doubts. I think we should continue. Alright. So in the next example, I want to show you how this cloud computing can be used to share even the computational power more than resources, right? So let us jump into it. Alright, here's the second example where you are a regular user who has a regular PC. This PC comes with these specifications. You have a Intel i5 7th generation, you have Intel UHD 617 graphics, you have 4 GB of DDR4 RAM, you have got 128 GB SSD and 1 TB of HDD, right? So this, wait, if you find it difficult to understand, well, you don't have to. It's just a regular computer that works well when it comes to browsing, when it comes to watching YouTube, or just working with some kind of spreadsheets and PowerPoint, right? So this is a regular machine, right? But one fine day you get an idea about gaming. So how about gaming? But the problem is this configuration cannot run simple titles as well. So what's the solution? Well, Google Stadia has come up with a new platform. Google says their Stadia can handle high-end gaming on your regular PC. Well, how is that possible? Now imagine there is a computer in the cloud with these specifications. It has got an Intel i9 10th generation CPU, 4 GTX 2080 Ti's, 128 gigabytes of DDR4 RAM, 4 terabytes of PCIe Express link storage. And once again, if you find it difficult to understand, again you don't have to, because this means simply that this is a computer that can handle, it can crush anything you throw at it. So games will run buttery smooth. What you can do is you can simply connect your computer to the cloud computers that Google offers you in the form of Stadia and can enjoy high-end gaming, right? So now I think we should modify our definition that we studied earlier. Cloud computing is the on-demand availability of computer system resources, especially data storage and computational power, without direct active management by the user, right? Okay. Now if there's anything you find difficult to understand, or it was something like my pronunciation or my language, do let me know in the comments. I will repeat it once again. Alright, I think we should proceed. Now in this example, assume that you want to run a website, right? You have got two options to choose from. Either you can go with private server or you can go with the cloud-based server, right? But before you take a decision, there are some parameters to take in mind, to take in consideration, right? The first thing is there are some cons that come with the private server. Alright, the first thing is its cost. Private servers are expensive, not just expensive, they are goddamn expensive. Just a minute. Alright, thank you. So private servers are very expensive. I mean, they take a lot of money, right? And you know what is not expensive? Subscribing to the channel. So why don't you go and subscribe, right? The next thing is frequent maintenance and monitoring. Private servers, or say any servers are first of all very intensive machines. So any server you choose requires a lot of monitoring. They have to be continuously monitored, because since a lot of people are getting connected to your server, so it's a possibility someone breaks into your database, someone misuses the vulnerability, right? So there can be some issues. Alright, the next thing is scalability. Well, I would like to take some extra time to talk about scalability, because alright, imagine that you have a user base of around 10,000 users, and you calculated using your statistics that within 1 month you will be having 20,000 users. But unexpectedly what happened was your number of users rose to 1 lakh. Now your server cannot deal with 1 lakh users at the same time, because your server was having enough capability to deal with maybe 20,000 users or 30,000 users, right? So at the spot you will have to purchase either new servers or get your instances running somewhere else as well, right? The next thing is, the next problem that you have with cloud computing with private server is low efficiency. Now why is it so? Now imagine you purchase new servers, now you have strength to deal with around 2 lakh, maybe 4 lakh users, right? But your website is facing some downtime, and because of that only 10,000 users or say 20,000 users are on your website, which means your rest of the power that is active to handle 80,000 users is going waste, right? And this is what decreases the efficiency. The next point is accidental damage. Well, suppose that your servers are kept in a building, and because of some natural calamity, maybe there's a fire in the building or there's some short circuit in the building and your servers are broken, means physically damaged, right? This will cause your whole instance, all your instances to shut down, and if you don't have a proper backup, it's going to take a lot of time for you to get your website once again up and running. The last con is latency. Suppose your server is kept somewhere in Noida or say in Delhi, right? And because of that, there is a user who's sitting in Australia. For him, your website takes around maybe 10 seconds to load, just because your server is kept so far away, it's kept in a different continent, right? And a user who's sitting in India, for him the time it's only about 2 seconds, right? So because of this latency, it is a possibility that you may lose some image in the market, right? Now, how does cloud computing solve these problems? Let's look into them. The first thing is cost. You don't have to pay for the servers at all. You only have to pay for the rent or for the time you are going to use the servers, right? Second thing is maintenance. You don't have to maintain the cloud-based servers because the people who own it, maybe it belong to Microsoft or they belong to Amazon. So they are the people who are gonna take care of the maintenance or the monitoring as well. So you don't have to take care about maintenance. Since you save both time as well as money, you can focus on growing your own business, right? Alright, the next thing is scalability. Scalability is very easy over here and it's very highly efficient. How? Consider the same example that I gave you before. Suppose you have a user base of 10,000 users and suddenly unexpectedly your user base becomes 1 lakh. No problem. These servers, cloud-based server are easily scalable. You can modify the storage. At the same time, you can create more instances if you need, and can shut down instance if your website faces any downtime, and those resources can be used by some other person whose website maybe is in more demand, right? So this is how cloud-based server are more efficient. The next thing is accidental damage. Well, nature affects everything, but over here you are more secure because you can have your backup, the backup of your instance. Suppose you have installed your instance on a server which is situated in North America, right? And you will be having a backup somewhere in Australia as well. So if there is because of some natural calamity, your servers or the infrastructure is broken over there, your instances from Australia can take over and your website can still run, right? The last thing is low latency. Since cloud-based servers are available in more and more countries, in more and more continents at the same time, users from around the world are gonna face almost the same latency, right? Which is very good for your image, for your business idea, right? All right. Now, if you look closely, before you look closely, let me know if you understood till now whatever I have said, right? Do let me know in the comments. All right, Entertainment Studios, no doubt. Thank you. Tandav, shout out to you. All right. So if you look closely into the IT departments of multiple companies today, right, they have a separate department for analytics, a separate department for networking, for database, and there's a bunch of coders lying around. So more and more IT companies are now moving, not only IT, every company are moving their database to the cloud services. Why? Because they believe when cloud can handle their database in a much better manner, why don't they give the job to them? and secondly, it saves them time, both time and money, and they can spend more time and money on the business itself. Why am I using time and money so much time? Yeah. Anyway, now we have finally come to the conclusion, why do we need cloud computing and what are its advantages. Till now, any doubts, do let me know. So should we move forward? All right, let's move forward then. On the basis of service models available in cloud computing domain, we have got 4 service models right now. The first one is SaaS, stands for software as a service. Next we have got PaaS, platform as a service, and then IaaS, infrastructure as a service. Finally BaaS, backend as a service. Well, backend as a service is a new service model that has emerged in past recent years. So we'll be talking about all of these one by one, right? So the first one is SaaS, software as a service. Just a minute, I think it's not visible. All right. In the case of software as a service, the cloud provider leases the application or software which are owned to them, and they just give it to their clients for the use. That's it. They can't own it, right? The client can access the software using any device that is connected to the internet, whether if it is a tablet, a smartphone, a laptop, anything, right? And they can simply use the software, pay for the service, and then just, yeah, the business is over. Best example I can give you is the Microsoft Office 365, which is an online version of the MS Office suite that is very popular amongst the business class. So they charge you maybe annually or monthly, it's your choice, and you can simply use their services, right? Yeah. The next example is PaaS, platform as a service. All right. In this service, the cloud provider gives the customer the ability to launch the applications, to start their services on their platform, right? The platform can be anything. It can be either Windows or Linux. Given that the customer cannot interfere with the underlying architecture, not even the operating system. If it is Windows, it has to be Windows. If it is Linux, it has to be Linux, right? The best example I can give you is the Azure, that is the Azure service that Microsoft provides you. It has got Microsoft Windows operating system pre-running over there. You can install your applications, you can launch your business, you can scale your activity itself, right? The next thing is IaaS, infrastructure as a service. All right. Now this is also pretty similar to what we saw previously in the PaaS, but the only difference is the customer can now even control the underlying architecture, including the operating system, which is a blessing for the customer, right? The customer can modify, can have Windows if he like. If the customer wants, he can have Linux, he can have Ubuntu. It's the customer choice. The customer cannot interfere with the actual physical machine, cannot interfere with the storage, but the customer can have his own software or his own operating system running, right? So the next thing we have BaaS. Well, nowadays this is becoming very popular amongst the cloud service providers. Why? Because in case of BaaS, the company does not target the customer. Instead, they target a developer, so that this developer uses their API into their applications, so that their applications deliver better performance to their customers in turn, right? Sometimes this service gets confused with SaaS as well because of its usability. Look, in case of SaaS, you are giving whole software to a customer for use, but in case of BaaS, you are sharing only a particular ability of the software to a customer, to the developer, in the form of an API. What does API stand for? Application Programming Interface. Well, we are not gonna dig so deep into it, but this is what it is, right? One of the best examples, we have got Parse backend. That's what we're gonna discuss in detail today, and we have got Firebase backend as well, which is owned by Google right now. All right, let's move forward. So this diagram clearly explains you how what is the differences between IaaS, PaaS and SaaS based on the powers or the rights a user has or a customer has over the infrastructure, right? You can take a reference to it. Well, you will get this in a PDF format as well in the description below. You can download it from there as well, right? Let us move forward to the deployment models. All right, recently we talk about the service models. Now we'll be talking about the deployment models that cloud computing firms offer us today, right? So the very first model we will be discussing is public cloud. The next is private cloud, and finally the hybrid cloud, right? So let us see what is in this public cloud first. In a public cloud deployment, the services which are deployed are open to public use, and generally public cloud services are free, right? Services like Google Cloud. Now, why did I take the example of Google Cloud? You might be saying that your service, it's completely private, yeah, your files no one can access. But wait a minute, if you share a link to the file to someone else, they can access your Google Drive file very easily, but only the file whose link you share. And this is why Google Drive cannot be considered into private cloud. It's a public cloud, right? The next thing is the private cloud. Well, private cloud technically is very similar to what a public cloud is, right? The only difference lies within the security and privacy. Private cloud are very secure. So private clouds are generally handled by the company itself or a third party company for a different company. Like AWS can handle this for a different company. For if I have my own company, AWS can handle it for me. The only difference is all the files and the infrastructure or my account will be accessed only by to those people who are authorized or whom I allow to do so, right? And the next thing is hybrid cloud. Well, if your company uses a combination of both the types of cloud, a private cloud as well as a public cloud, then it becomes a hybrid cloud, right? Now, how do they work together? Consider an example. Suppose you have a company that does research on biological on the environment, right? So you have a lot of PhDs lying around you, and there are a lot of papers, research papers published from your company as well. So they are so generally you'll be dealing with two types of documents. One will be either the paper is finished, and the second will be the paper on which the work is still going on. So the paper whose research is over and is ready to be published can be sent to the public cloud, whereas the paper that has to be kept private, whose research is still going on, should be kept in a private cloud. So this kind of setup is known as a hybrid cloud, right? All right. If there are any doubts, do let me know before we proceed forward. Alright, let's move forward. So let us quickly discuss some of the cloud service providers that we have in the market, right? So the first one is AWS, Amazon Web Services. Second is Microsoft Azure. Next is Google Cloud, and then the Alibaba Cloud. Well, there are many other companies in the market, but these four are the ones who are dominating it right now. And in today's webinar, we are going to talk specifically about AWS because of some of its cool features that the company offers, right? So let's look into them. The first one is the market share. Look, AWS alone has got a 32.6% of market share, whereas the nearest competitor, Azure, has mere 17.6%. Well, 32.6% doesn't look such a huge number, but still AWS is currently dominating the market. It has largest user base right now, which is a big deal. Well, this doesn't mean that Azure is completely blown out of the water. Look, the second thing is server capacity. Well, there's no doubt if there are 100 servers in the world, 86 belong to Amazon and mere 14 belong to other companies, and this is a huge thing. Here you can't question anyone, right? The next thing is flexible pricing. In case of AWS, you have to pay only for number of hours you use a service, right? So this is why flexible pricing is very important for any business. Alright, the next thing is why we are not picking up Azure is AWS started in 2006, right? And Azure started in 2010. And just because AWS started 4 years before Azure did, AWS has a better infrastructure, it has a better model of cloud computing. So, and yeah, the numbers speak for themselves, and you can't argue the numbers, right? So let us dive in. So these are some domains that are available in the AWS domain, in the AWS architecture, in the AWS cloud, right? So the first one is the compute domain. The next we have got migration, we have got security and identity compliance, then we have got storage, networking and content delivery, messaging, database, and some management tools. Look, we are going to discuss every domain, but we are not going to discuss every service in detail because we are limited to time, right? So the very first domain we are going to discuss is, it's the cloud computing domain. So here we have a very popular service known as EC2, where what you get is a fresh computer. You can install anything over it. You can install a Windows, you can install Linux, you can install Ubuntu, and you can configure it to be anything. It can either host a website, it can host an application, it's just like completely new PC, right? You can make anything out of it. The next thing is migration. Alright, from the name itself it is pretty clear. It's about moving data, or it's about transferring data from one place to another. Well, yes, you guessed it right. It is about transferring data from your premises to the AWS infrastructure and bringing it back to your premises, right? But the thing very important over here is the snowball service that AWS offers. Suppose you are dealing with petabyte scale of data and you wish to have this data on your AWS infrastructure, and obviously you can't transfer petabyte scale of data over the internet to the AWS infrastructure because it's gonna cost you a lot of money, right? It will be very costly for you and for them as well. So AWS has worked around it. They have made a device known as Snowball, which is just like a huge hard drive which has a large capacity. You can store petabytes and petabytes of data. Whenever you request it, they send you this Snowball to your premises where you can install or where you can download all your data, and then they ship it back to the AWS infrastructure and the data is uploaded to the servers, right? So this is how the Snowball service works in migration domain, right? Then we have got security and identity compliance. Suppose you have a huge business and you want to restrict tasks of different employees. So you can have an employee who has the power to change the instances but cannot launch it. And the other hand, you can have an employee who can only launch the instances but can't change it, right? So you can divide the workload, you can give security, you can look for security and other stuff, right? Next thing, you have the storage domain. Alright, the storage domain has services like S3, known as Simple Storage Service, which is an object-based file system where you store files, all kind of media files, let it be a video, a movie or music, anything, right? The next thing is networking and content delivery. Alright, so this includes services like Route 53. And for those who don't know what Route 53 is a DNS service, which stands for Domain Name System, that redirects your traffic to the images or to the instances that you have in the AWS infrastructure. Your domain can be you can purchase the domain from anywhere. It doesn't matter whether it is from GoDaddy, it is from Big Rock, or is it from Google itself directly, right? So this is what happens in the networking and content delivery domain. The next domain, we have the messaging domain. From the name itself, it is pretty clear. It's about sending messages, right? The superpower here is that if you wish to send messages or send emails in bulk, you can do it right away with a single click, right? So this is the liberty that AWS offers you. The next domain is database domain. Well, database is also used to store data. It has got services like RDS, relational database service, which is not a database in itself, but it can manage your databases like MySQL. It automatically updates your DB engines and commit to your changes, right? So this Amazon says they have their own database known as Aurora. Well, they even can say that it's 5 to 4 times faster than MySQL that prevails right now. But this is what they say. Alright, the thing to notice over here is both database and storage are used to store data, right? But don't get confused amongst these, right? The storage can store any kind of data, but database only stores a specific type of data. For example, the database of students studying in UCER Greater Noida, right? There will be a field called name, there will be a field called roll number, there will be a field called phone number, there will be an email, your parents name, mother's name, father's name, right? So this is what is database. And if you ask me how do these database and storage work in harmony, I would like to take the example of YouTube. So whenever you go and click on any link on the YouTube, it first go and checks in the database where this video actually exists in the storage, right? So there is an address in the database. It go and checks the address and uses this address to take you to the video available in the storage, right? So this is how database and storage work together. All right, the next thing we have management tools. Well, this is the last thing. Here, management tools are used simply to manage your AWS infrastructure. There's nothing rocket science. It only has a new service known as this CloudWatch that can help you watch everything at the same time. You can keep an eye on what's going on in your infrastructure. You can launch images as well, right? Alright, it's time for the doubt session. If there are any doubts, do let me know, guys, and yeah, I'll be waiting for you. Alright, looks like there are no doubts. Wow. So yeah, it's time for the demonstration, right? So sit tight, let me make some configurations over here. Alright guys, the settings are done, all done, right? What you're looking over here is a example of what parse backend is, right? So by the time it gets loaded, I would like you to see this. So if you want to set up a parse backend, right, you can use it. You can do it very easily using this back4 app service. You just have to go and log in over here. You can use it you can use your GitHub account or your Google account, simply log in. Where I've already logged in, I'll get to my dashboard, right? So I've already created a simple application for you guys. All right, so this is the application, the student. All right, now I would like you guys to go to the description, and you can just download it from there. Wait a minute. All right, you can scan this QR code if you wish to download the app. You can try it on your own as well, right? By the time I run it over here. Alright, if you go into the API reference, creating an application is very easy using this parse backend, and you can do that very easily, right? Alright, here's the documentation from where you can see all the codes are already available for you. This will help you to configure your application very easily. You just have to go to the introduction first. You can install the SDK directly into your software, right? And yeah, I'm into my Android Studio. Alright guys, now what I would like you to do is you just have to go and download the application from the link given in the description, right? Or you can yeah, you just have to download it from there. And as soon as you sign up, you will see your name over here. All right, Aman, thanks for signing up, right? Go on, guys, try it. So there's someone, Ria, thank you. अरे भाई तेरा स्लेयर गेमिंग, थैंक यू. लुक एट दिस गाइस. चलो यार, थैंक यू वेरी मच फॉर ज्वाइनिंग टुडे. इट्स अ ग्रेट सेशन. मज़ा आया. आपको ही मज़ा आया तो बताना यार कमेंट्स में. एंड या ईद मुबारक सबको. कोरोना में ज़िंदा रहना, ठीक है, सुरक्षित रहना, आबाद रहना. ऑल राइट, चलो बाय बाय.